thought I'd make a video answering some questions that I've had in the comments on the previous video on roughing this radius on the aluminum piece of plate, and the distortion that it had. And I had a few questions on the pallet changer in the machine and how it works to keep shavings out of there and everything, and you know, maintain precision when it does a pallet change. So let's go in and look in the machine here for a second. It's easier to just show you this rather than try to explain it. And I'll have the machine make a pallet change here. Let's see if I can position the camera, or I'll just start the pallet change. Let me just start it. And I'll see if I can show you here. See, the hook is coming out to make the change. And listen, maybe you can hear it. Did you hear the air blowing? And here's the pad, one of the pads right here that the pallet sets on. Let me get a little bit more light on there. Can you see the little holes in the pad? This is where air blows out. When the pallet lifts up or goes down, the air blows out those. And it blows out shavings out from underneath there. And then of course we got the pins here, and the one way over there that orients the pallet in a rotary direction. But if you mess with these shavings like now, if I would start blowing air around there and everything, or sweeping them, I could get shavings up on top of those pads. So it's kind of better not to mess with it, to tell you the truth. Although I do get in here and clean this out, and when I do, I make sure all of those are clean when I do it. But I've owned this machine for, I don't know, like 15 years now, and I've never really cleaned the bottoms of the pallets off, and they seem to come in and out with pretty good precision. Let me see if I can get a video image of the underside. Let me just see. Kind of hard for me to get an image under here, but you can see right here is where the bushing, where the pin goes in, and right next to it over here is where the pallet sits on the pad. I can't see it very well myself looking at the monitor on the camera, but right here somewhere is where that pad sits. Right there, I've got my thumb on it right there. You can see it keeps it pretty clean. And also the pallet overhangs on the side here, all of this a little bit, so it keeps stuff from getting in there too when it's in the machine doing some machining. I don't know if you could see that or not, but like I said, I've owned this machine for probably 15 years, I think, at least, and I've never cleaned the bottoms of those pallets off where they sit on those pads before. So I also want to answer some questions about the distortion of the material. I got to make some sketches, so I got to set the camera up so I can do that. But I want to answer that one question because I got quite a few comments on that, believe it or not. You know, how does it go in and out, and how does it keep things clean? And that's the way it does it. It blows air up through those pads, and apparently if a shaving gets between that pin and the bushing, it just shears it off when it pulls the pallet down. There's two big hydraulic cylinders that clamp that thing down. I don't know how much force it clamps down with, but it's quite a bit because it's pretty strong. All right, I got a different mic set up. I hope this is working better. It is. Still got the fan blowing on me because it's hot in here today. I live in Houston. It's always hot in Houston. But anyway, I want to talk a little bit about what happens to materials when you machine it and why you get distortion in the material. Now, most of it comes from how they manufacture the original material to begin with. When I get a piece of or a drawing that calls for like a part made out of 1018 cold rolled steel, and it's like a flat bar with notches in it and things like that, that's a big concern to me, because cold rolled material has the most stress in the surface. let's just draw. Let's imagine this is a bar of material, and when they roll it in the rollers, you know, to draw it out to the length, or however they do it, it puts extra force in the surfaces, of course, particularly cold rolled material, because it's compressing it down to size. You're basically forging it. You know, all material, pretty much all material actually you get is forged, except for cast pieces, and particularly aluminum. You know, the only real cast stuff is the cast plate, you know, like the tooling plate and stuff. The rest of it is either extruded or forged. Now, extrusions can be a little bit better, but these bigger pieces of plate are actually forged down to size in rolling mills, like what I'm dealing with here. So this puts this compression in the surfaces, and because it's done on both sides at once, it's pretty much balanced. So when you get the piece of raw material, it's kind of flat, you know, so it's not bending. So if we look on the top view of the part that I was dealing with here, and we got this compressive force in both faces that's balancing itself. When I start cutting a big notch or a radius in it on this side, this force is pushing outward on this face, but I've relieved the force in here. There's no balance anymore, and so to exaggerate it, the part warps this direction like that. It's you know, giving to that force, and it's closing this side down on the radius side, just like you saw in the video of the previous video. So the forces on most material you get is sort of balanced when you get it, but when you start cutting into it, you relieve those forces, and it's got to go one way or the other. Now that's one way to put stress into the material when it's manufactured, and the other way is you can actually put stress into the material when you're machining it, which any machining operation does to some degree. But depending on the cutting tools you're using, it can put more force than others. Like a bigger face mill facing across a piece of stock will tend to put more. It pushes more material back into the part than, say, a smaller diameter end mill that cuts a little cleaner. And the more negative rake tools will do that too. They push material into the stock. So if you're trying to face a flat piece of material that's thin with a face mill, for instance, like I did a video a while ago on facing down some titanium pieces that were 800 thousandths thick to 3/8 of an inch, I believe, and I had to maintain about 4 thousandths flatness of the pieces, and that's kind of a difficult thing to do when you're doing it with a face mill, because if you let the inserts get dull, it tends to expand the surface of the material where you're cutting, and it warps the part away, kind of like this, from the surface, because it's expanding the surface. It's putting this compressive force back into the material the way you're cutting it. And if you're really interested in holding something flat, oftentimes it's easier to do it if you're using a smaller diameter end mill, because the end mill cuts cleaner. It's got more positive rake geometry than maybe a face milling tool has, and you take many passes over it, and you put less stress into the material. So that's another way to warp apart machining it. You can either be relieving stress in the existing material or pushing it into there yourself by the way you're machining it. So I did get that question, you know, like, does it always move the same direction? Yes, it pretty much always does, because when I was cutting into this radius on this part, this force is always pushing outward and bending the part this direction. So, you know, this is I mean, I'm no metallurgist or anything, but this is my experience, what I've seen happen when I've been machining parts. Now, if I get a lathe part, you know, that's a round part, the stress is pretty much evenly distributed in the surface of a round rod or bar. But then when you start cutting away notches in it, like many of the parts I've made, you've relieved this stress and the part warps. I made a tubular part once that was a kind of relatively thin wall tubing. I think it was 17.4 pH, and the guy that ordered the material had it drilled and honed on the bore. And when I got the material, I told the guys, and I told the people, it was a job for centerline, but I told them, man, you know, this part had a big keyway cut the full length of the part like this in the OD, and the wall thickness was I don't know, maybe a ½ inch thick, and this was I can't remember, but about 8 inches in diameter. And this ID was honed, bored and honed to 32 finish and everything, and it had to be round within like 2 or 3 thousandths. And I told him, I said, man, you know, when I cut the keyway, I think it had a keyway there, and then it had a couple of smaller keyways. I can't remember exactly, but I told him, man, when I cut those keyways the full length of the part, this thing's going to egg and go out around. And sure enough, it did. See, the better process would have been to do this milling, this turning and milling, and leave some stock in the bore, and then come back and finish that bore after we did all those things. And in fact, I think we had to re-skim the bores after we did it. But see, this is relieving the stress. You got these compressive stresses all the way around this round bar, but then you cut into it and you relieve it, and the thing just wants to change shape on you. Like I said, I think this part had, I can't remember, I think it had a couple other keyways, smaller ones, and maybe 120 degrees, I can't, but this tends to turn the part into a triangular shape when you cut these keys in there like that. And that's exactly what happened. I mean, it's not a lot, but it's enough to throw it out of tolerance. You know, in many YouTube videos, I've seen people weld on things. Welding is another way to throw things out of tolerance, or you can even straighten things with welding if you do it correctly, like or with heat, like Keith did on Turn Right Machine. He straightens shafts with the torch and throwing water to cool the spotty heats, and you can straighten a big huge shaft that way. There's a lot of force involved with just a little, you know, heating and maybe a spot, you know, a ½ inch in diameter, almost red hot, and then throw water on it and quench it, and it'll bend a big huge shaft. There's that much force involved. So anyway, these are the ways that things cause distortion in metal things, parts. But most of the time it has to do with the way the material is manufactured and maybe subsequently heat treated. Now, there's often a lot of comments on videos about, oh, you can send it to be stress relieved or this or that, and yes, you can do those things if you're able to do them. But in a modern machine shop nowadays, you have certified materials, so you got all these certifications that you have to get around. So you can't just send something to the heat treat place without having the whole batch of material retested. So you have to have a test sample, you have to have tests done. It's very expensive and takes time, and you have to have the customer's permission to do such a thing, because you're changing the certification on the material that was purchased for the job. So you can't just, you know, willy-nilly send stuff out to the heat treater and anneal it or stress relieve it or do stuff like that, you know, because you just can't do that nowadays in a machine shop. I mean, I don't know if there's a time you could, but now you can't do that kind of stuff. So, you know, even though it sounds plausible, and the only way you could do it is if you get permission from the customer, and then you're going to have to run some new test samples. So you're going to have extra stock to run test samples on. So usually not a solution. You usually have to work with what you have. So you got to think of ways to machine things to get them to the proper dimensional tolerance. Now in the past, I didn't have any trouble with this material for some reason, but these new batches of material I'm having trouble with, and I should have been doing it this way all along, because this is the way to avoid all of that, the way I'm doing it now. And I got lucky up to this point. For many years I got lucky, but now I have to change my procedure for this reason. So anyway, I hope these few things answer some people's questions a little clearer in the comments on the previous video. So thanks for watching.